So let's draw a few events on a space-time diagram. So this is X and the usual T, and let's have an event A right here, an event A in space-time. Let's put an event B here. So that's event B, and let's put an event C, say here. Okay, so clearly, from the perspective of the XT observer, we have that the time for event A, which is, or we move horizontally this way to get TA. TA is clearly earlier than TC, which is that. So we have TA earlier than TC, which is earlier than TB, which is the latest time. So we have that time sequence from the XT perspective. Let's now consider an observer that is moving fairly quickly, and so the spatial axis of this observer, let's say, goes through event A, and so we'll go like this, and that would be X bar. And so I want that angle to be the same here, sort of like that. Seems about the same. That's T bar. And so we can look at the sequence of events from the perspective of the X bar T bar observer. And when we do that, we see that we have to move parallel to the X bar axis to get the time. So to get the time for these events, I have to move along this way. So here's the T bar time for event A. So TA bar would be this, and TC bar, I would have to go parallel, and I would have to come down here. So maybe we can just extend the time axis so that we can see that, in fact, TC bar is down there. Right, so that would be TC bar, and TA bar is here, and TB bar is that. And so what we see is that TC bar occurs earlier, before TA bar. So event A occurs after event C from the X bar T bar perspective, and event B is always the latest event to occur from both perspectives. So what we see is that events A and C have a different kind of sequence, right? So here is A happening before C from one perspective. Here is event C happening before event A from another perspective. What's going on here? And the answer is that they are not causally connected. And so we can see that by drawing the light cones. So the light cone of event B looks like 45-degree lines like this. So those are all the future events that event B can influence, and all the past events that event B can be influenced by. Event A is in the past light cone of event B. So event A can influence event B. So there can be a causal connection between the two. And we can see this from the perspective of event A, where the light cones for event A, the future light cone for event A looks like that, and the past light cone for event A looks like that, sort of. And so A and B are causally related because they are in each other's past and future light cones. Event C instead has past light cone that looks something like that, and a future light cone that looks something like that. And you can see that these events are not within those light cones. And so we can say that the time sequence between events that are not causally related is not an invariant quantity. So A to C is not invariant. That's what we get from one perspective. And so we can see that from a different perspective, it's C to A. That's the sequence from that other perspective.